Today I'm going to be talking about building a custodial Lightning wallet the right way. So we're going to use Cashu to do that. And thanks to Ega for giving that great presentation on kind of an intro to cashu-ts, because that's what we're going to be using today to build this wallet. But we're going to kind of focus on some of the other challenges with building a Cashu wallet, which he avoided in that presentation. So we're going to talk about state management and like using multiple mints and swapping funds between mints. And we're also going to talk a little bit about how you can hold ecash in different currencies across mints. So my goal with this workshop is that anyone that wants to follow along and write some code should be able to. So there's these two links here. There's a Replit and then also just the GitHub repo. So I'm not sure how it'll be with the internet, but I recommend, if you can, use the Replit because everything should just be set up. You may need to make a Replit account, but once you do, then you can just fork this and you'll have the boilerplate code, which is all here. And then a really nice thing about Replit is I've put this tutorial in here, so if you go to the main GitHub repo, you'll be able to see this, but with Replit, we should be able to, let's see, how do I find this? Once you have the Replit open, you should be able to search for tutorial, and it'll kind of open it up in this nice way with a table of contents, and you can also create a new tab over here so you can work on editing your code while following along with the tutorial here. But if you don't want to use Replit or if the internet's too slow, there is also the GitHub repository and instructions to get it started there. So those links will be on the slideshow for the next couple slides. And I'm saying this is building a custodial Lightning wallet the right way because we're using Cashu, and it's basically, instead of you having to custody your users' funds, you can use the mints as the custodians, and your users kind of get to pick their custodians, and I think it's much simpler as well. But I'm not necessarily saying that the way that I've chosen to go about building it, which is using cashu-ts and Next.js, I'm not saying that those are the best way to build this, but I think that Cashu or ecash in general is a great way to build a custodial Lightning wallet. So you're here, you want to build a Lightning wallet. Some other options are build a node into the phone. So those are like Mutiny or Phoenix. Has its upsides, but it's also extremely complex. Another option is ask your users to run their own node. So that could be something like Zeus or Clams that basically provide a front end to your Lightning node, and you can just connect to it. But most people aren't going to do that. Or you can hold your users' funds with something like Wallet of Satoshi, but then you have to worry about being a custodian. So I say build a Cashu wallet because it's simple. You can offload the custodial responsibility to the mints. It's Lightning compatible. So what we're doing today is not even really going to be sending and receiving ecash. It will look pretty much just like a regular Lightning wallet. You can have stable balances, so your users can hold synthetic dollars like EUSD. And also, it's way more fun. Here's an example from the Cashu wallet that I'm building, where we're sending around eGIFs. So my goals for today are to build a Cashu wallet that is interoperable with the Lightning network. We'll be able to send and receive Lightning payments, hold multiple currencies, and swap between mints. And then also just generally, I want to provide a framework for you to go and build your own Cashu wallet. So maybe you don't necessarily want to build a wallet like we're going to, where the single purpose is just to be a wallet, but maybe you want to integrate Cashu into your app like Shopster has done so that your users can have payments natively in the app without having to leave. And also, I'd like to inspire you to build some Bitcoin software. There's no experience required for this workshop. Anyone can do it. It might be hard, but especially if you take this home and maybe ask your friendly neighborhood LLM for some help, I'm sure you can figure it out. So on that note, I just want to mention pleb devs, which is a project that I help work on that is a community of plebs figuring out what it means to be a dev. So you can go to plebdevs.com, and we have a Discord and a YouTube channel where you can kind of start to get involved, and we have a bunch of workshops on there where you can learn more about Bitcoin and Lightning development. We also do some Nostr stuff as well. So yeah, with that, let's get into actually building this. Does anyone have any trouble getting set up that wants to follow along? Everyone all good? So I'm going to start by just giving kind of a tour of this repository here. So here in the .tutorial directory, if you're not on Replit, you can see these markdown files and follow along that way. We have most of this is a Next.js project, so most of this is auto-generated. But in here, we should have this package.json file, which is kind of where all our dependencies are and some scripts that are useful. So the main library that we're using here is the cashu-ts library, which Ega showed us how to use earlier, and then just some like icons and a QR code library so that we can scan the Lightning invoice. And so if you're, this should work just right out of the box on Replit, but if you clone the repository, you may have to run npm install, and that will install all of these dependencies. And then here in the pages directory, we have a couple pages. The app and document are auto-generated. So in the document, I have just set this title and imported a font. And then in the app file, this is kind of like the main structure of our app. So I have these like nav items here. So we can hit run on Replit or npm run dev in your terminal. And the cool thing about Replit here is we should be able to open this in a new tab. And so this is what it'll look like. Zoom in a little bit. And I like to, when I'm building apps like this, work with the console open here. So you can usually right-click and hit inspect, or on Linux here I did Control-Shift-J. And then here we have like the console where any log output or errors will show up. And then this network tab is really helpful when we're interacting with the mints, because oftentimes the mints will return an error, and you can see that here even if your code doesn't necessarily catch it. And you can see the requests that you're sending and the responses that you're getting. So, what we have here is the home page, and this will be able to add new wallets and then select which one will be our active wallet. We will send payments by pasting in a Lightning invoice. We will receive payments. It'll generate an invoice. And then once that gets paid, we'll get some ecash in our browser. We can transfer between mints. And then I'll just demonstrate here kind of what it would look like to send offline, which is a cool feature of ecash, because the money is stored directly in our browser. So we may not have the exact amount that we want to send, but if we're okay with overpaying a little bit, then you can send money offline. Let's see. Just going to close these tabs. All right, and I'm going to have the tutorial open on one side, and then on the other, we will write some code. So before we get into oh, I guess I'll go over a little bit more of what we have here in the boilerplate. I went over the app file, and then each of those pages that I was showing you there, which I think I accidentally closed there we go. Each of these pages here is kind of maps to one of these sidebar items. And then we have these hooks, which is where most of our logic is going to be. So in React, hooks are just kind of these functions that act almost like classes and allow us to manage our state and kind of make building the app a little bit easier. And then our CSS styles are in here. I set this project up using Tailwind, so we don't need to do too much in here. Tailwind looks like this. You can add the styles directly to the HTML here, which just makes building the app a little nicer. So, and then back here, just some prerequisites. None really, but if you want to understand this workshop the best, there's the nuts, which are the cashew specification. So this is kind of where the rules for cashew are defined. So you can go and check those out. We're actually not going to be using nut04, which is what defines how you swap one token for another. We're mostly going to be using nut5 and nut6, which is how you mint and melt tokens. So that flow looks something like this for minting tokens or creating ecash. The wallet will request to the mint. It'll say, I want to mint tokens. And the mint will respond with this quote. And here, this field quote is going to be the quote ID. And then request, in this case, we're going to be using bolt 11. So the request will be a bolt 11 invoice. The state here will be the state of the quote. So it'll start out as unpaid. And then once we pay it, it'll change to paid. And then once the ecash is issued, this state will change to issued. And then there's this expiry, which is sometimes used and sometimes not. Usually if there's a exchange rate, like if you're minting USD tokens, then there will be an expiry. So we get this quote, and then the wallet user will pay the invoice. And once the invoice is paid, then the wallet will send these things called blinded messages to the mint, and the mint will receive those, sign them, and return blinded signatures. Then the wallet receives those and creates proofs, which it can use to later prove to the mint that the mint did in fact issue this ecash and owes this wallet some Bitcoin. So now the wallet has minted ecash, and now in order to melt it or pay a Lightning invoice, it will destroy that ecash. And it does that kind of in the opposite way, where it gives the mint an invoice that it wants the mint to pay, and the mint will return a quote that looks a little bit different. It's got this quote here, which is the ID, and then the amount of ecash that the mint wants in order to pay that invoice, along with a fee reserve, which is the estimated Lightning fee. And then the state of the quote, when it expires, and then once the payment is complete, this payment preimage should be populated. So we get this quote, and if the wallet likes it, we send some proofs to the mint, and the mint validates it, destroys that ecash, and pays the invoice. So, getting into it, first what we're going to need to do is add a wallet. So the UI is all built out here, but it doesn't actually do anything. So what we want to be able to do is enter a mint URL here, and then get a wallet that we can start minting and melting ecash from. So that's all going to happen inside of the wallet manager hook. So we can see in the index file here, we're importing these 4 functions, or I guess it's 2 functions and then 2 values, the active wallets and wallets. And so when we click this search button here, it's going to call lookup mint, and we're going to find the units that that mint supports. And then once the user selects a unit, then we're going to call handle add wallet. So in handle lookup mint, you can see we're calling this lookup mint function, which is not yet implemented. So that's going to be inside of our utility file here. And we just need to copy all of this code into the lookup mint function. So what this is doing here is it's using this cashu mint constructor from cashu-ts, and it's creating a new mint with the URL that we pass in. It's getting the mint's info from its info endpoint, then getting its key sets, and then finally here we are basically just, the mint can have multiple key sets, as many as it wants, and each key set will support a different unit. So we're just looking through all of those and finding the units that this mint supports and returning that. I'm returning it like this because if we wanted to add more functionality to this lookup mint function, if we wanted to return more info, we could do that here, like from this mint info endpoint. Right now I'm just logging it so we can see what that looks like. So now that we have this in here, we can add a mint, and we're going to need to find a mint. I put some test mints here, or you can go to bitcoinmints.com and filter for cashew mints. Well, now I'm filtering for both. And then just pick a mint that you want. I'm going to go with the CoinOS mint. Actually, let's go with the stable nut mint, and here we'll see multiple currencies. So we paste this, and this is going to call the lookup mint function. Calls search. You can see here in the console we've logged the mint info, and it supports these 3 currencies. So this drop down gets populated. We're just going to pick sats to start. And now we need to implement add wallet. So that will happen here, and that's all going to be in the use wallet manager hook. So this hook is for managing all of your wallets. So your app may have multiple mints, and then each mint may have a wallet for each of the units that the user wants. So here's a bunch of these are React hooks that just help with managing the state of this component, because sometimes when the screen re-renders, then this gets lost. So these utilities help us maintain state. And then we also have some other helper functions like set active wallet. So that will get called when we change wallets here. But we are going to implement add wallet, and add wallet is going to accept the mint URL along with an optional unit, or it'll default to sats. So in here, we are just going to copy over here. So first we need to create a new instance of the mint class. And then we are going to look at all of the mint's key sets and find the key set that matches the unit that we want. So maybe this is a little bit redundant because we already looked that up in the lookup mint function. So if we wanted to, we could pass the key set around, but here this is just a little bit simpler. So we're basically calling mint.getKeysets here, and then looping through and finding the one where the unit matches the unit that we passed in. And then here we're also just testing to make sure that the key set ID is in hexadecimal because cashu-v0 was not hexadecimal, and then we upgraded to cashu-v1, which is the new spec, and those key sets are in hexadecimal, so this way we're kind of just ensuring that we get the v1 key sets. And if we can't find it, we'll throw an error. But we already looked up the units that the Mint supports, so we should find a key set that matches. And this .get keysets function, I'm pretty sure just returns the kind of metadata about the key sets, but not all of the public keys. So each key set will be a list of public keys for each amount of proof that the Mint supports. So they'll have, and they're all powers of 2. So the key set will have public keys for like 1, 2, 4, 8, etc. So once we get the key set ID that we want, we will need to actually get the public keys. And here I'm just, this returns a, or keys response.keysets is an array, and we passed in the keyset ID, so it should just return one single keyset. But here I'm just kind of making sure that we got the keyset that we wanted by looking for the keyset that matches that ID, but there should only be one. So now in keys, we have the Mint's public keys. And now we can initialize a new instance of cashu wallet. So you can initialize it with just the instance of the Mint, but you can also pass in these wallet options, which I've laid out here. So you can pass in the unit, the keys, and a mnemonic or seed if you want to have deterministic secrets, which will allow you to back up your ecash with something like a seed phrase. So the reason that I'm passing in the keys here is because we already found the keys that we want, and if we didn't, then cashu-ts would select the keys for us. And another nice thing about this is that we won't have to like refetch the keys every time. So now that we have this wallet initialized, we'll just kind of update our state. And part of that is adding the wallet to local storage, where we're actually going to store the keys. That way we don't have to refetch all of the public keys every time. And then finally, if we don't have an active wallet, which is the case for us right now because our app is not, we just started it, so we'll set the active wallet to this one that we are adding. So that should be it for adding a wallet. Here's the whole function if the way that it was up here is confusing. But basically what we did was we fetched all the Mint key sets, and then we found the one that matched the unit that we want, and then we saved all of that data in local storage and added it to our UI state. So now here, I need this Mint again. We should be able to look it up, choose sats, submit, and now we have a wallet and a balance here. So we can also, again, search for this Mint, but pick USD. And so now we'll have two different wallets here from the same Mint, but a different currency. So I can switch between USD and sats. And so now we want to actually get some ecash in this Mint. So we're going to have to, well actually, before we can do that, we're going to need to initialize this wallet when we reload the app. So right now if I reload, it'll look like it's disappeared. We don't have any wallets. But if we check out our local storage, we'll see that all of that data that we stored is still there. But it's not showing up here because we don't have any logic to initialize it. So all of that's going to happen in this use effect. So use effects have this thing called a dependency array down here. Right now it's empty. So this means that everything inside of this block will run a single time when the app loads. And if we put any variables in here, then anytime those variables change, this will run again. But all that we want right now is just to call this load function when we reload the app. So to do that, we just need to add to this load function. And here you'll notice it's a little weird. I have this function here, and then inside of it I'm creating a new function, and that's because use effects don't like it when you make them asynchronous. So we're basically creating an asynchronous function, and then we are going to call it here. So inside of the load function, we pull our mint URLs out of local storage, and then we're going to start by just logging them. So to show you what our local storage looks like a little bit, we have mint URLs, which is just going to be a list of all the mint URLs that we've added. And then we're going to have a key in local storage for each of those that stores all of its key sets. So here you can see we have mint URLs, which just has one. And then we'll be able to find those in local storage, and those will have the keys. So now that we have the mint URLs, we are going to initialize all of them. And here you'll see this kind of funky looking thing. This is called JSDoc. It just annotates the types. So this is all in JavaScript, but it helps us helps the code editor know what the types of our variables are, which normally it shows up when you, oh, there we go. So we're able to kind of tell the code editor what the type of wallets to initialize is, which just, I don't know, helps me figure out what I'm doing. So here what we do is we are mapping through the mint URLs, and for each one, we are getting its data from local storage, and then just returning its key sets. And then we are going to need to initialize the wallets. So that should, let's see, happen here. So there's two of these maps that we are going to fill, our wallets and our mint key sets. So because we have multiple wallets, we are going to be calling the mint's key sets multiple times, and so we don't necessarily want to, if we have multiple wallets for the same mint, we don't necessarily want to talk to the mint each time. So each time we talk to a mint for the first time, we will just store all of their key sets here. And then this is just going to be a placeholder for the wallets that we're initializing. And now we're just going to loop through each of the wallets to initialize. And you'll notice here that, so first we check if mint key sets, which is this map here, if that has, if our mint exists in there, then, or if it does not exist in there, we will call mint.getKeysets to fetch them. Otherwise, we will use the key sets from that map. And then in here, when we fetch, we have this inside of this try catch block. So this will most likely fail if you have no internet, or maybe the mint's down or something like that. So if it fails, we're just going to put a warning in the console, but then we are going to set the key sets to what we have already saved, and that will make it so that we can use our wallet offline. But we're going to try to fetch their key sets first, and then we will find the one that matches our wallet's key set ID. And we are going to make sure that the key set is active. So mints can rotate their key sets if they want to either maybe deprecate a currency or just force you to rotate your funds. So, or maybe they just want to stop accepting new mints, or like new, they don't want to allow their users to mint ecash. Maybe they like say we only hold 100,000 Satoshis in this mint, and if we go over that, we're going to set our key set to inactive. So what you might want to do here, right now I'm just giving a warning, but a good idea would be to, if it's inactive, find the mint's active key set, if they're rotating key sets, and then move all of your ecash from the inactive one to the active one. So now we're just kind of doing the same thing that we did in the add wallet function, but with all that data that we loaded in and initializing the new wallet instance. And then finally, we just need to update our state. So let's see if this is right. I think this is right. So we're going to set our wallets for this component to all the wallets that we initialized, and then set our active wallet based on what we had stored in local storage. And yeah, then this will call that load function. And now, if it worked, when we refresh, which it looked like it already did, we'll have our mints here. So now we're able to add as many wallets as we want with different currencies and then switch between them. So this balance is showing the balance of the active wallet, which you'll see once we get some funds in there. So yeah, again, here's the entire use effect if you want to copy that. And basically what we're doing is everything that we did in add wallet, but we're just kind of redoing it based on what we had stored in local storage. So now we're going to actually go and receive our first Lightning payment. So here you'll notice in receive that it just takes an amount, and what we have on the receive page is two things. We have that input for the amount and then this QR code, which will get populated with whatever title we want to set, which in this case is going to be Lightning invoice, and then the value, which will be the invoice to pay. So in order to generate that invoice, we need to implement receive Lightning payment, which will happen in use cashu-wallet. So use cashu-wallet is another hook which will help us kind of interact with the cashu-wallet class along with like the proofs that we have. So I guess before I show that, I will show you this third hook, which we're not going to implement. I've already implemented for us, called use proof storage. So this just uses local storage to keep all of your proofs, and has these two functions, get stored proofs and set stored proofs. So that'll be reading from local storage and then writing to local storage. And then we have this thing called a provider. So at the bottom here is where we're actually exporting the hook, and we're using this use context from React. And so what context does is it takes this provider and gives us a component that we can wrap our app in. So here I've wrapped the entire app in proof provider, and what this does is it basically gives everything inside of this, these 25 hidden lines, everything inside of there will have access to these same instances of these values. So if we don't do this, then for every page, like we do here, for every page that we use cashu-wallet, it will create a new instance of use proof storage, because use cashu-wallet is calling use proof storage. So every time use cashu-wallet gets called, use proof storage will get called, and then these values like balance and stuff won't be global for the entire app. So we want to wrap the app with this provider to get a global state. So in use proof storage, we are just returning these values. The most interesting are balance, which is and balance by wallet. So balance by wallet is how I'm showing this here, and it's just getting the balance for whichever wallet is active. And then we're going to be using the add proofs function, which will add proofs to our storage, and then we will remove them. So the way that I've implemented this, we have these two getters, get proofs by amount or get all the proofs for a certain key set. And there's not a really great way to do this in the web. So the way that I've implemented it is we first get the proofs that, say if we want to melt some tokens, we get the proofs that we want, then we attempt to melt, but the problem is the payment may fail, and so we don't want to just delete the proofs right away. We want to read them, send them to the mint, and then wait for a confirmation. And once we get the confirmation that the ecash has actually been melted, then we'll delete it on our side, and that will be this remove proofs function. So yeah, let's mint some ecash. So we're going to do that in use cashu wallet, and we need to implement receive lightning payment. So receive lightning payment is going to accept an amount and then a handle success callback. So you can see in receive here that we've just basically all that we do once the payment is successful is we stop showing our QR code and reset our state. And we're passing that in here. So this just kind of allows for some flexibility in terms of how we use this function and how we let the user know that the payment has successfully completed. So what we'll need to do is first get a mint quote for the amount that we want. And then on that mint quote, there's going to be this request, which will be an invoice and the quote ID. And now what I'm doing here is calling add pending mint quote, which is from the wallet manager. And this will basically just help us keep track of any outstanding lightning payments, because what's going to happen is next we are going to poll for the invoice payment. And if the user refreshes the page, for example, or if it crashes, then if we don't keep track of this pending mint quote, then it'll just be gone forever, but the invoice may still get paid. So what we're doing here is we're just storing it, and then once the payment is successful, we will remove it. So this gives us the option to kind of recover. If the user initializes the lightning payment, their app crashes, then they can reload and recheck to see if they can mint those tokens. So what we're doing in this polling function is setting this interval, which is just this set interval function, just comes right from JavaScript, built in, and we're setting it to 5,000 milliseconds. So every 5 seconds, we are going to do what is inside of this block. And what that is check the mint quote's status. So we'll look up the mint quote by its ID, and it has a potential couple states. So those are all on this mint quote state object here. It could be paid, issued, or unpaid. So if it's issued, then that means something went wrong because we're still looping, but the quote was already issued. So we hope that doesn't happen, but it might. Before the invoice gets paid, it'll be in this unpaid state, and we'll just loop again. But once the invoice is paid, then the mint quote will be updated to paid, and we'll call mint tokens, and we're going to get proofs. The wallet is going to receive the blinded signatures from the mint, and then cashu-ts will do the cryptography magic to unblind them and get these proofs. And then we'll add those proofs to our local storage, and then just kind of reset everything, clear the interval, call our handle success function, and remove the pending mint quote. And now, so this is just a function here called start polling. And so the reason that I did it this way is now what we can do is return, We can call start polling, so this will start the loop, and then we'll return the invoice. So you can see here in receive that we get the invoice to pay, and while we show that invoice to the user, this function will still be polling in the background. So let's see if this works. We're on the receive, and we're in sats, so this will receive 5 sats. It generated an invoice. I'll try to pay this with the Cashu wallet that is on my phone. If it loads, or I'll copy the invoice and pay it with Albi here. So you can see if it's working, it says we are waiting for payment. Okay, this is a bug that I was hoping would not occur, but it did. And I don't know why it's happening. This is something that's happening internally with cashu-ts. And I wasn't able to figure it out. So this means that we lost money. Because it's calling this, it's trying to convert the signature, the blinded signature from the mint to a point, and for some reason that doesn't work. But you can see here in the network tab that here's where we were polling the status of the quote, and here we are getting its status here, and at the end we see the state is changed to paid, and we can see that the mint returned, so we called the /mint/bolt11 endpoint, and it returned these signatures. So that all worked, and that happens in this mint tokens function. So the mint successfully returned the signatures, and somewhere inside of here something happened. And it did seem to be working for some other mints, but I couldn't figure out what the issue was. So let's see if we try just the test mint. So the regular testnut.cashu.space just got upgraded to support the key set fees, which charge a fee for every time you interact with the mint, but cashu-ts doesn't support that yet, so we're going to use the no fees version, and this way we can test this out without losing money. So now no fees is active. Let's see if that works. Let's receive 5 sats, and this one should get automatically paid here. So that worked. Now we have 5 sats. And it did the exact same thing, so I'm not sure what the issue is. But now we have 5 test nuts in here. And now we want to actually send. So from the user experience, this looks, other than having to add a mint here, I like to, for the Lightning Wallet use case, I like to think of this as kind of like a user-selectable custodian rather than being forced into this app being that user's custodian. So depending on like how you're building it out, you could say like choose your custodian here. And then from the user experience at this point, we're just receiving a Lightning payment. And now we are going to send a Lightning payment. So in order to do that, we will need to implement send Lightning payment inside of use Cashu wallet. So that will be here, and all that accepts is an invoice. So first we need to get a melt quote from the mint. And then what we're going to need to do from this melt quote is calculate the total amount of ecash that the mint wants in order to pay this invoice. So on this melt quote, we're going to have this amount and fee reserve. And the fee reserve is for the potential lightning fee, but we will get change if there is no fee. And then we're going to pull the proofs from our local storage, and we're going to make sure we're going to use this get proofs by amount function, and we're going to pass in the key set ID because we can have multiple wallets, and so that means we could have proofs from any key set. So we want to make sure we only get the ones from the wallet that we are using. And if we go look at what this does, it will return all of the proofs, which is this result, or null if it can't get them. So we just need to check and see if we didn't get any proofs, then that means we have an insufficient balance, and we'll throw that error. And then we just call the melt tokens function, where we pass in the melt quote and the proofs that we've selected to melt. And this function will return change if there is any, a Boolean value that says whether or not it's paid, and a pre-image once it is paid. So now we will just finalize it with this code here, where if it is paid, then we just log that. And this is where I was showing you. So here we're reading the proofs, but they still exist in local storage. And then here we actually remove those proofs to send because it's paid, and we add our change. Otherwise, we don't really have any error handling here. We just log that it failed. So now we just need an invoice to pay, and because this is the test, we need an invoice, but it's not actually going to get paid. So I'm going to generate an invoice for 4 sats. And so see here, it actually wanted 6 sats. So we can look at, this is the melt quote response. So it asked for an amount of 4, which is what we said that's how much the invoice was, but there was a fee reserve of 2. So we don't have enough money to do that. Let's generate an invoice for 3 sats. And here we get the melt quote, which this time was amount of 3 and also fee reserve of 2. And then here we called melt tokens, where we pass in our proofs, and then these outputs are for change. So just in case in case the lightning fees were overpaid, which in this case they probably were. So yeah, you can see here we got change for 1 sat, which we were cheated there because this didn't actually make a lightning payment, so there was no real fees. So yeah, that's sending a lightning payment. And now I think this is probably one of the trickiest things to do, is a cross-mint swap. So I'm not sure if I'll be able to get it to fully work because of the issue with minting tokens, but let's just try another mint to see what happens. So the idea here is that we have ecash in one mint, and maybe we want to distribute our funds across some mints, or we just want to change who our custodian is. So we, on this tab here, we'll be able to select another wallet to transfer our funds to. And right now we're only going to be able to transfer to a different mint, and of the same currency. And there's 2 reasons for that. So ideally, we would be able to transfer within the same mint to a different currency. So if I'm holding dollars on this mint, for example, and then I wanted sats, I should be able to transfer those over. But the way that most of the mints are running Nutshell, and the way that works right now, it's not a protocol limitation. It's just the way that Nutshell works, that won't work. And then we are also not going to be transferring between units across mints, because that would require us to do some exchange rate conversion on our side. And that's just out of the scope of this workshop, but something that you could totally implement. So in order to do this, so here I explain that we cannot transfer funds across units within the same mint, but we are going to be able to swap across mints. So that is going to happen inside of use cashu wallet in this cross mint swap function. So this cross mint swap function accepts a cashu wallet instance that is called 2, so that's the mint that we're swapping to, and the proofs that we want to swap to that mint, and it's just going to return the total amount that we swapped. So we can check this out in the transfer page in handle transfer. So this is going to call get all proofs by key set ID. So we're basically just going to melt all of the proofs from one mint and transfer them over to the other. But if we wanted to, we could just transfer like half the balance or whatever. And then, so we're reading those in, and then once it's swapped, we are going to remove those. And just a UI choice here, we're going to set the active wallet to the mint that we swapped to, because we're kind of removing all the funds and assuming that we don't want to use that mint anymore and moving them over to the other one. So back in the cross mint swap function, here we passed in the wallet to swap to, and then this whole hook takes in our active wallet here. So just to kind of help us keep track of things, we're saying that from is our active wallet. So we're swapping ecash from our active wallet to whatever mint is passed into this function. And then here, just to prevent that, saying that we don't want to do the exchange rate, I'm just checking to make sure that the unit of this key set is equal to the unit of the key set that we're swapping to, and if it's not, we will throw an error. And then here, we're just kind of validating the proofs that we passed in. So we are getting all of the key set IDs of these proofs, and if there's no proofs, we're going to throw an error. This is checking if the size is greater than 1. So if we got proofs with multiple key set IDs, then we'll throw an error because we want them all to be from the same key set. And if the key set ID does not equal the wallet that we're swapping from, we'll also throw an error. And now we are going to calculate the total amount that we have to swap. So that's going to basically just add up the amount of all of the ecash that we passed into this function. And now this is where things get a little weird for cross-mint swaps. Or also if you are trying to melt all of your ecash, you'll run into a similar problem here. So remember, we have that fee reserve, and if we tried to, say we have 10 sats, if we tried to melt all 10 sats and generate an invoice for 10 satoshis, then that fee reserve is probably going to end up equaling something like 12, and we won't have enough, so we won't be able to pay the invoice. So what we have to do is loop until we find an amount and a fee reserve that are less than our total proof amount. So then I'm also just setting the attempts here just in case something happens and we can never find a valid melt quote. That way we don't go into an infinite loop. So here I'm just setting up some variables and the loop. And then now we are going to actually try to find the quotes. So first we get a mint quote, and we get the invoice from there, and then we're going to get the melt quote from from the from mint, we're going to pass in the invoice from the mint quote. So this is, we need to pay this invoice with our ecash in order to swap our funds. And now we basically just kind of check to see if we got valid quotes. So the amount required to melt is going to be the melt quote amount plus the fee reserve. And if that's less than or equal to the total proof amount that we have, then we will break the loop. Otherwise, we're going to subtract the difference between what we have and what we need, and then reassign this amount to mint variable to subtract that difference, and then try again. And hopefully it only takes a couple tries. So assuming here we're able to find a valid mint and melt quote, then we can actually melt the ecash and mint tokens on the other side. So that will happen here. So this is going to look familiar to what we did earlier when we were receiving a Lightning payment, except for instead of paying the invoice with Albi or whatever wallet you have, we're going to have one mint pay the other mint. So that looks like this, where we mint tokens. Here, first we have to melt the tokens. So in the from mint, we are melting the tokens, which is paying this other mint. So then we just check to make sure it's paid and just remove those proofs. Even though we haven't minted anything yet, these proofs are going to be spent, so we don't want them. We don't want to store them anymore, otherwise it'll mess up your state. So now we mint the tokens and then just calculate how much we minted, add our new proofs and our change, and then return that total amount. So let's see if we can get funds into 2 actual mints. So let's go with CoinOS, because we can't do this with test mints because they don't actually make Lightning payments. So we have CoinOS here, and let's try to put 10 sats in there. And it worked. So I don't know why that happens, but sometimes it happens and sometimes it doesn't. So now let's pick another mint. I don't know. See if this one works. 21mint.me. So now we're adding this one. It looks like it was able to find it. So now in our list, our active wallet is CoinOS, and then we have this other mint that we're going to try to swap to. So we choose that one, and we just click transfer. I'm going to open up the console here so we can see what it looks like. So attempt number 1, attempt number 2, and it seems like it found it. And then there's another error. So this is when we are trying to remove proofs, which is these. Oh, I guess on this side we called remove proofs also, so that is not supposed to. We're not supposed to remove the proofs twice because they won't exist anymore, but it should have still worked. So see, we're left over with these 2 sats, but if we switch our active wallet to 21mint, now we have 8 sats in there. And the reason that we have 2 sats left in this mint is we should be able to see that in here. So this is all these Bolt 11 requests are. Let's see if I can make that a little bigger. How do I scroll up? Well, so basically here it's looking for a mint quote and then a melt quote. And so this was the first attempt where the amount plus the fee reserve was 12, but we only had 10 sats. So it tried again. And here it got an amount of 8, fee reserve of 2, so that we had enough ecash for. But then once we actually called melt, we got change back. So the mint estimated that it wanted to pay 2 sats for the lightning payment, but at the end of the day, there was no fees, or for whatever reason, they gave us change. So now we have 2 sats left in here. So if we wanted to, we could try to, this is still our active wallet, we could try to swap again. But if they give us a fee, which, yeah, so this, basically we're never going to be able to get those 2 sats out because this melt quote asked for an amount of 2 and a fee reserve of 2. And we only have 2 sats, so we're kind of stuck here. But that's okay. You could donate them to the mint if you want, or if we added more ecash in here. But it seems like because this mint is asking for a fee reserve, but then returning change, we're just kind of stuck with that. So yeah, that is, oh yeah, then I guess we have, I didn't show it here. The last thing we have to do is send offline. So that could be a good way to use our last 2 sats here. I don't have it in the tutorial, so let's see if the code's already written or what I did there. Yeah, so we can just look at this. So basically, there's this button, send all offline, and when we click that, it's going to call handle send all, and all that's going to do is get all of our proofs for that mint. And if we don't have any, it'll throw an error. Otherwise, it will take those and it'll just encode those proofs into a token, which includes the mint URL, those proofs, and then optionally the unit of our active wallet. And that's just kind of helpful for whoever you send it to. They know what unit it's coming from. And then here is just setting the token in our UI. So this is all that it takes to send. So you notice we never do any async await or anything. We're never talking to the mint because we have the ecash right in local storage. You can see it here. We have these proofs. So we're just pulling those out, and it's probably going to be this one because it's 2. And then encoding it as a token. So you can see how that works when we click send all. So now you could copy this and send it to someone. And ideally when you're sending ecash, so if I'm offline, I'm never going to be able to talk to the mint. So this is what I have to do. And if you're planning on sending ecash offline, then you would want to implement some sort of intelligent coin selection. I think that's coming soon to cashu-ts, so you won't have to implement it yourself. But the idea is that if you intelligently ask for change that kind of makes it so that you can create any amount, then when you want to send offline, you'll have the proofs that add up to the amount that you want. So like in this case, if these were all in the same mint, we have 2, 8, and 1. So if we wanted to send 6, we wouldn't be able to. We'd have to overpay by sending 8. So that's just a limitation of sending offline. But if you have a lot of ecash in here and you're intelligently selecting this that you create, or you could kind of over time swap for different amounts where these can add up to whatever amount you might want to send, then you'll more likely be able to send the actual amount once you're offline. So as a sender, when I'm offline, this is what I have to do. But there's also the option to receive ecash offline. If we're both offline, then you would kind of have to trust me if I was sending you ecash, because this is just regular ecash. Anyone can put it into their wallet and spend it, and I can also reclaim it. So I could go and buy some bananas offline, send you the ecash, and then I could run back to internet and reclaim those tokens before you could get them, and basically double spend you. So that's how it is if we're both offline. But if the receiver is offline and the sender is not, then that means I can talk to the mint. And so what I can do there is swap these tokens that I have here for tokens that are locked to you. So we can do a pay-to-pub key lock, where you could give me your public key, and then I can swap for ecash locked to you, send it over to you. You check and make sure that it is in fact locked to your public key. And with that, you'll know that I can't double spend you because I don't have your private key. So that's a nice kind of way to do offline sends if the receiver is offline. So yeah, that's it. If you wanted to lock the ecash, that happens. We actually we haven't even used the send function, but what you can pass into send, we can just say to.send, and we can see here that we're able to pass in a public key. So if you use the send function, you can pass in a public key, and that will basically just swap the ecash for ecash locked to that pub key. So yeah, there's a lot more that you can do with ecash, but this is kind of all of the basic Lightning functionality that you might need. Does anyone have any questions? Cool, thanks for coming. If you want to get more into Bitcoin development, again, go check out plebdevs.com. We got a bunch of YouTube videos there. Thanks for coming.